Today, we're talking about Apache Kafka. This is the tech that takes the total chaos of data communication and turns it into something, well, orderly and lightning fast. So let's just dive right in. So your app's growing. That sounds great, doesn't it? I mean, more users, more engagement, more data. What's not to love? Well, here's the thing. As you scale up, the way all your different services talk to each other can suddenly become your number one problem, your biggest bottleneck. It turns out, growth without the right architecture, yeah, that can be a huge problem.
So let's start with a problem that, well, you've probably seen it before. We're calling this, Section 1, the data traffic jam. Okay, so picture this. In a pretty standard setup, your services are all talking directly to one another, right? So a user does something simple, like they like a post. That one little like service then has to go make direct API calls to, let's see, the notifications service, an analytics service, probably a feed update service. And before you know it, you've got this absolute tangled mess of connections. It's what we call a spaghetti architecture, and for good reason.
And this is where the pain really starts. This slide lays out the consequences of that spaghetti mess. Just think about it. If your notification service goes down for, say, just 1 minute, what happens to all the likes from that minute? Poof, they're gone, just lost forever. Or what if a post goes viral? Now you've got 1 million likes a second, just hammering your other services with API calls, and you're just waiting for something to crash. Everything is so tightly connected, so tightly coupled, that the whole system becomes incredibly fragile and really, really slow. So the big question is, how do you fix this? How do you untangle that mess? Well, you have to stop all those direct point-to-point trips. Instead, you need to build a central, kind of like a data superhighway. And you guessed it, that is exactly what Kafka is all about. Let's just break that down for a second. Distributed just means it runs across a bunch of servers so it can handle just massive amounts of data. No problem. An event streaming platform, that's key. It means it's not built for static batches of data. It's built for a continuous, real-time flow of events. Every single like, every click, every transaction, it handles it the moment it happens. And look at this. This is the after picture. This is the solution. Instead of all those services talking directly to each other, now they all just talk to Kafka. The like service, it just publishes a like event to Kafka, and that's it. It moves on. It's done. The notification service, the analytics service, they just listen to Kafka and pick up the events they're interested in whenever they're ready. And the best part? The service that created the event, the producer, doesn't even know or care who is listening on the other end.
Okay, so that's the big idea. But how does it actually work? Let's pop the hood and take a look at the engine inside. You know, it's actually pretty simple when you break it down. A single Kafka server? That's called a broker. When you group a bunch of them together for more power and to make sure nothing gets lost, that's a cluster. Now, the apps that send data to Kafka, like our like service, we call those producers. And the apps that read data from Kafka, those are consumers. That's it. Producer writes, consumer reads. Pretty elegant. Right, so producers don't just, yell into the ether. They publish their messages to a specific place called a topic. And the best way to think about a topic is, it's just like a table in a database. You'd have a user likes topic, an orders topic, a page views topic. It's just a way to keep all your different data streams nice and organized. Okay, so we've got this central hub. But what makes it so mind-blowingly fast? And how does it not lose data? And how does it keep everything in the right order? Well, this is where the real magic of Kafka's design starts to show. Okay, you want to know the secret to Kafka's insane speed? It's one word: partitions. See, a single topic isn't just one big log. It's broken up into multiple parallel logs, and we call these partitions. What this means is you can have multiple consumers reading from the same topic at the same time, with each one just handling its own partition. That's the parallelism. That's how Kafka can scale up to handle millions of events every single second. But wait a minute, this should raise a really important question for you. What about the order of the events? If you're just spreading messages across all these partitions, how do you keep things in order? Because by default, you don't. The solution is brilliant, though. You send your message with a key. For instance, you'd use the user ID as the key. Kafka makes one simple promise. All messages with the exact same key will always go to the exact same partition. And just like that, you've guaranteed that all the events for one specific user are processed in the right order. It's that simple. Okay, but what happens if a server dies? What if the broker that's holding one of those partitions just crashes? This is where the fault tolerance kicks in. Kafka is constantly making copies or replicas of every partition and it stores them on different brokers. So for any single partition, one broker is the leader. It handles all the writing. The others are just followers, and their only job is to copy what the leader does. Now, if that leader broker goes down, no problem. Kafka just automatically promotes one of the followers to be the new leader. The whole thing happens behind the scenes, totally seamless. And what's the result of that incredible leader-follower system? It's simple: zero data loss. The system is built from the ground up to handle server failures without losing a single message that it's confirmed. And that, my friends, is a huge deal.
All right, so the theory is amazing, but what does this look like in the real world? How are developers actually using this stuff today?
Well, the first thing you should know is that, yeah, you could go and install and manage your own Kafka cluster from scratch. But honestly, most developers just don't do that anymore. We use managed services like Confluent Cloud. They handle all the messy stuff, the setup, the scaling, the maintenance, and it just lets us focus on what we actually want to do: build our apps.
And getting this into your code, it has become so simple. If you're using a framework like Spring Boot, for example, you can literally just take a normal method, add one little annotation on top of it, add Kafka Listener, and bam, just like that, that method is now a real-time data consumer that's automatically listening to a Kafka topic. It's almost ridiculously easy to get started processing live streams of data. Okay, let's pull all this together. When you think about all these features, the topics, the partitions, the replication, what is the one huge fundamental change they give us? It all comes down to one thing: the power of decoupling. This slide is really the so what of it all. With Kafka, your producers and your consumers are totally, completely decoupled. They don't even know the other exists. This means you can scale different parts of your system totally independently. You can survive server failures without losing any data. And you can build a much more responsive asynchronous system where services aren't just sitting around waiting on each other to finish. So if there's one thing to take away from all this, it's this: Kafka isn't just another message queue. It's way more than that. It's like a central nervous system for your entire data architecture. It's durable, it's reliable, and it's scalable. It's the backbone for real-time analytics, for event-driven apps, for pretty much everything. And that really leaves us with one last thought. By letting you listen to every single event right as it happens, Kafka basically gives your data a voice. So the real question for you to think about is, if your data could talk to you in real time, right now, what would it be telling you? What insights, what user behaviors, what incredible new opportunities would it reveal?